Hello dear friends, myself Nitin, and today we will be studying about mechanism of Indian monsoon and rainfall pattern. So note down this topic, mechanism of Indian monsoon and rainfall pattern in India. So this topic is also a part of physical setting paper 2 Indian geography. So as we used to do it, we will be studying this topic also in a very structured manner. So I would request you to have a copy and pen with you and note down the important points and important keywords from this lecture. So as we do, we will be first writing down the headings which we will be covering under this main topic. So you also please write down. First thing is that what is monsoon? Second thing is what are different types of monsoon. Third, we have description and types of Indian monsoon. Fourth one is origin and mechanism of Indian monsoon. Fifth one is factors affecting Indian monsoon. Sixth heading is characteristics of Indian monsoon. Then seventh is impact of different phenomena like El Nino, La Nina. Then we have Indian Ocean dipole. Then we have subtropical westerly jet stream. Then we have easterly jet stream. Then we have Somalian jet. Then we have Walker circulation. Different phenomena like ये over Indian monsoon. So we will study about all these terms and all these phenomena which we generally used to see in the news, and also we will see that what is their impact over the Indian monsoon. Seventh one is this. Now eighth one is features of Indian monsoon. And finally, ninth one is significance of Indian monsoon. So I hope you people have noted it down. These are the 9 headings which will be covering under this main heading, mechanism of Indian monsoon and rainfall pattern in India. If you have people have noted it down, then we will start with the first one, means what is monsoon. We will start with our first heading, that what is monsoon. See this term monsoon, this has been derived from an Arabic word named as Monsoon, and this word was first given by the Arabic navigators while they were traveling from Arab to means India or South Asia during in the tropical region during the month of June and July. So they observed a particular kind of wind pattern and they named it as monsoon, and later that monsoon came to be known as monsoon. So we will see that what is the definition of monsoon. You can note down the definition. Monsoon is a wind system characterized by seasonal change in wind direction resulting in seasonal change in precipitation. So this is the definition for monsoon. You can note it down. You need to write this definition at various places wherever you will be asked means any question from this topic, mechanism of Indian monsoon and rainfall pattern. So this is the definition for monsoon. Monsoon is a wind system that is characterized by seasonal change in wind direction resulting in seasonal change in precipitation. So note down few keywords here. You can underline the keywords present in this definition. Wind system, seasonal change in wind direction resulting in seasonal change in precipitation. So mark down these 3 keywords. I will explain to you that how this actually, what does it actually mean, seasonal change in wind direction. See what happens in this monsoon is characterized by in the month of June to October, the direction of this monsoon wind is from southwest towards northeast, means southwest towards northeast. This is the direction for this monsoon wind. Monsoon winds. Now from June to October they blow from southwest to northeast, while on the other hand in the month of October to December the same winds, they 180 degree, they show a 180 degree reversal in their direction, 180 degree reversal in their direction, and they blow from northeast to southwest. So this is the keyword, means this is the meaning of the keyword here, seasonal change in wind direction. June to October is one season and October to December is another season. In the June to October the winds are moving from southwest to northeast, while in the months of October to December the winds are moving from northeast to southwest. So this is the meaning of seasonal change on wind direction. Then we have seasonal change in precipitation. What do you mean by seasonal change in precipitation? See here, in the months of June to October, when the winds, these monsoon winds are blowing from southwest to northeast, means they are blowing from ocean towards land. So of course, when a wind will blow from ocean towards land, it will have lot of amount of moisture content in it. So a wind having lot amount of moisture content in it, when it will be blowing towards land, it will precipitate there. It will means due to condensation, it will lead to precipitation in over the land region. So on the other hand, in the months of October to December, when these winds are blowing, means in the opposite direction from northeast to southwest, they are blowing from land towards ocean. Then of course, when a wind blows from land towards ocean, this will not have moisture content over in it to cause precipitation. So what will happen that these winds, while northeast to southwest, these winds means they lack precipitation. These are known for heavy precipitation. So this is the meaning of these keywords under the definition of monsoon. I hope you people have understood it and noted it down. If you people have noted it down, we will also understand about this in when we will be studying about mechanism of monsoon. So first note down this. Now we will be moving to our next heading, that is types of monsoon. We have three types of monsoon here: tropical monsoon, subtropical monsoon, and temperate frigid monsoon. You can note down all three types of monsoon. Basically, we will be studying about this tropical monsoon because this is only in our syllabus. Now, this tropical monsoon means Indian monsoon becomes a part of this tropical monsoon. We have to study about Indian monsoon, and that is part of this first type of monsoon, that is tropical monsoon. Indian monsoon. So we have to study about this tropical monsoon. Under that also we have to study about Indian monsoon. So this Indian monsoon has been divided into two parts. First one is southwest monsoon, and north east monsoon. Now this southwest monsoon, it has two arms, west arm and east arm. And this northeast monsoon, it is nothing but it is characterized by movement of main winds from northeast to southwest during October to December. Now this west arm of southwest monsoon, it has three branches. One is towards Saurashtra and Kutch region of Gujarat. Next branch is Maharashtra and Central India. And the third one is Kerala and Western Ghats. Do remember this, make down this flow chart. This will help you to understand this topic in a better manner. Then we have eastern arm. Eastern arm is related to West Bengal and Assam. Over the Bay of Bengal region. From over the Bay of Bengal region, and this one is from Arabian Sea region. So I hope you people have noted it down. Means this tropical monsoon, Indian monsoon is a part of this tropical monsoon. Indian monsoon is then again divided into two parts. One is southwest monsoon. This one is from June to October, or you can write it that June to. And then we have northeast monsoon. This northeast monsoon is from October. We have written it. It is a movement of wind from northeast towards southwest from in this manner, and it is from October to December. Then we have southwest monsoon has two branches. One is western arm and second one is having eastern arm. Then in western arm we have three portions: south Saurashtra and Kutch region of Gujarat, Maharashtra and central India, and Kerala and Western Ghat region. And eastern arm we have West Bengal and Assam region, that is from over the Bay of Bengal region. From this winds from Bay of Bengal region. So if you people have noted it down, we will come to our next topic, that is mechanism of Indian monsoon. Before that, we will see the few points about origin, means origin of Indian monsoon. Then we will come to mechanism of Indian monsoon. As far as origin of Indian monsoon is concerned, we mainly have two concepts under this, means origin of Indian monsoon. One is the thermal concept or the classical theory, and another is dynamic concept. We will study about these two, but before that you can write down these characteristics of Indian monsoon, because many times direct question is asked that you need to mention the characteristic of Indian monsoon in 5 marks or 10 marks. So just note down this, then we will come to this origin of Indian monsoon, and then we will try to understand these two concepts. So under characteristic of Indian monsoon, first characteristic is that it is a tropical phenomena. So what do we mean by this? It is a tropical phenomena. We know that the tropical region lies from 23.5 degree north to 23.5 degree south. So this monsoon is observed between this region. We have seen that means since the winds movement, this monsoon winds movement is in between these two latitude. So that is why it has been named as tropical phenomena. You just need to remember here that this is what is in theory, but in actual, due to apparent movement of the sun, we know that in the month of June the sun rays are directly overhead of Tropic of Cancer. It means over here. While in the month of December, the sun is directly overhead over Tropic of Capricorn. That means over this latitude. So we know that with the apparent movement of the sun, the ITCZ means intertropical convergence zones also used to shift. So means the actual area doesn't remain between these two latitudes. It used to shift 5 to 10 degree upwards, as well as 5 to 10 degree in latitudes towards southwards also. So, but in actual, but in theory, since this monsoon winds used to lie between these two latitudes, so we have named it as tropical phenomena. So this is the first characteristic under Indian monsoon. Next is 180 degree change in the wind direction between summer and winters. We have already seen this, how there is 180 degree change in the wind direction. We have seen that from in the month of June, the winds blow in this direction from south west to northeast, while in the months of October to December, means from June to October, the wind direction is from southwest to northeast, while from October to December it is from northeast to southwest. So we see that there is 180-degree change in the direction of winds. So this is the second characteristic of Indian monsoon. Note down this. And the third characteristic is rainy summer in the northern India, while dry spells in most of southern India. What does this mean? See, when during the month of June to October, when the southwest monsoon due to the southwest monsoon, the winds are moving from ocean towards land. When they are moving from ocean towards land, they will be carrying a huge amount of moisture with them, and they will cause precipitation here over the land. But it is saying that this rainy season in the northern India, means northern and central India, you can write here northern and central India, but while dry spell in most of southern India. So see what happens here, we have Western Ghats. So what happens that these Western Ghats are having good height, so winds are not able to, also these Western Ghats have very lesser number of passes, means the winds are not able to cross this Western Ghats, So what happened that eastern portion of this Western Ghats here in southern India, this portion used to remain dry from southwest monsoon. Means the southwest monsoon winds, they used to cause maximum rainfall over the western side of this Western Ghats, means over this region, while this region used to remain dry. The winds, what happened, the southwest monsoon winds, they used to move from this area into central India and northern India, and they used to cause, means they are responsible for precipitation here in this portion. Secondly, the eastern branch, means the southwest monsoon, we have two branches. One was just this branch, means Arabian branch, and second one is this Bay of Bengal branch from here. So what happened that this branch, this used to cause rainfall here in means West Bengal region, Bihar region, parts of Odisha, and in Assam region. So that is why we are seeing that from the during the months of June to October or summer months, maximum rainfall is caused in northern and central India, while this eastern part of southern India, that remains dry. The other part of this is that rainy winters in the parts of southern India, that is Andhra and Tamil, and dry spells in north and central India. What happens that during the northeast monsoon, see this monsoon, northeast monsoon, it is the winds are blowing from land towards the ocean. So when winds are blowing from land towards the ocean, they will not be having moisture content in it. So what will happen that when the winds will blow from, even the winds are blowing from this region, they won't be causing any precipitation here. Means though no rainfall will be here in central or northern India. But what happens, the same winds when will be blowing from here over Bay of Bengal, the same winds when they will be blowing over Bay of Bengal region, they will what they will do, they will carry few amount of moisture with it, and that the same wind when it will come back to land over here in Andhra and Tamil Nadu, then that northeast monsoon or the winds of that northeast monsoon, that will be causing rainfall here in Andhra and Tamil Nadu in the months of November and December. That is why we see floods in Chennai in the months of December and January, or we see heavy rainfall in the southern part of Andhra Pradesh. Why that is? That is due to northeast monsoon. And this northeast monsoon, while it is dry here, when it passes through this Bay of Bengal region or this region, means it carries it starts taking moisture from this ocean or water surface, then it used to cause rainfall in this region. So this was the third part of this characteristic, means in the winters, while the northern and central India is dry, there is rainfall in Andhra and Tamil Nadu region. So these are the three characteristics of Indian monsoon. I hope you people have understood and noted it down. Now we will move to our these two concepts, thermal concept and dynamic concept, which are a part of origin of Indian monsoon. We will start with this classical theory or thermal concept of monsoon. Actually, this theory is the simplest theory available among all the theories, but the major problem with this theory is that this could not explain all the features of the monsoon. So we have various other theories. So we will start with this theory and see that what this theory says. This theory, classical theory or the thermal concept, is mainly based on specific heat difference in specific heat capacity of land and water, which results in differential heating and cooling of land and water. So note down under this heading, classical theory or thermal concept, that this theory is based on difference in the specific heat capacity of land and water, which results in differential heating and cooling of the land and water. See, what do you mean by specific heat capacity? Specific heat capacity means the amount of heat required by an object or by a substance to raise its temperature by 1 degree centigrade. So what we have, that the specific heat capacity of water is higher than that of land. So what does it mean? It means that water require higher amount of means heat or higher amount of energy to raise its temperature by 1 degree centigrade in comparison to land. It means land gets heated as well as it gets cooled very quickly in comparison to that of water, or water takes much time for that over land. So what happens, that we know that an area having a high temperature will have low pressure above it, or we know that an area having low temperature will have a high pressure above it. And we know that winds always flow from high pressure area to low pressure area. This is the basic concept which will be applied here. So what happens, that in the month of June and July, when the sun rays or the sun is directly overhead here over Tropic of Cancer or 23.5 degree north, or in the northern region. So what happens, that due to this land surface, means both land surface as well as this water surface in the tropical region both get heated up to a higher temperature. But what it happens, that land means getting more heated as compared to water. A low pressure area is developed over land, due to continuous heating or direct heating by the sun rays. The air present over this land surface, it gets warmed and it starts rising up. On the other hand, in this ocean, in this region, the same ocean part, the air above it doesn't get heated up to such an extent, and so here a high pressure area is developed while low pressure area is developed in this region. High pressure here means in comparison to this area, a high pressure region exists. So what happens, that wind start moving from this direction towards land. So this is for in the month of June to July, according to this thermal concept. Due to differential heating of this land and this water, due to difference in the specific heat capacity, a low pressure area gets developed here over the land. Why? Because land gets heated up more in comparison to this water, and high pressure area gets developed here over this region. Why? Because water doesn't get heated to such an extent in comparison to land. So wind start moving from this high pressure area to low pressure area. Contrary to this, in the month of October to December, just opposite happens. What happens in the month of October to December? The sun rays used to move in the southern hemisphere, and in the month of December, those sun rays used to be directly over Tropic of Capricorn. So what happened that the southern means this region means is not under the influence of sun, and this region gets cooled up to a certain extent that a high pressure region develops over this region. And what happens that water means this water start becoming a low pressure region in comparison to this region. So we know that winds start blowing from high pressure to low pressure, so the direction for the winds get reversed here in the month of October to December. So this was according to the thermal concept, mean due to difference in the differential heating of land and surface during these two different seasons, we see a difference in the direction of winds or in the difference in the direction of the monsoon. So this was a thermal concept. Now we will be moving to other concept of monsoon. Next we have dynamic theory for Indian monsoon, and it is also known as equatorial westerly theory. This was given by a geographer named as Flohan. So this is known as dynamic theory. Why? Because it is related to shifting of the pressure belts. Since it is related to shifting of the pressure belt, it is also known as dynamic theory. So before we start with this theory, I would just like to brush up this ITCZ concept, intertropical convergence zone. Here the name suggests intertropical convergence zone. Means intertropical means in between the tropics. Convergence zone means a place where means winds moving from two different directions used to converge or come together. So if I draw a line here, considering this as 0 degree equator, I draw a line here considering this is to be 30 degree north equator, 30 degree north of equator, and I would draw a line here 30 degree south of equator. Then we know that this region 30 degree south and 30 degree north region, this region are a high pressure region, while this 0 degree is low pressure region. Why this is low pressure region? We know that due to continuous heating of the sun, means at this equator, the air present here that used to heat up get warm and it rises. So this used to make this region a low pressure region. And why means both this 30 degree north and this 30 degree south is high pressure region? Because we know that at these 30 degree north and 30 degree south, air from the upper atmosphere used to descend, means upper atmospheric air descends, means it used to come down at these 2 points, and that is why these two regions are high pressure region. Now we know the basic that winds always move from high pressure to low pressure. So winds will move from this portion to here and from here to here, but they won't be moving like this direct in a straight manner. The winds won't be moving like this, rather they will move like this. Now why it is so that wind is not moving in a straight manner and it is moving like this? This is because means the earth is rotating from west to east. Now when the earth will rotate from west to east, it will also change the direction of this wind, and these winds rather than moving straight, they will move in this slanting way. So this is how the winds actually move. Now these winds are, since they are coming from northeast direction, these are known as northeast trade winds, and these are coming from southeast direction, they are known as southeast trade winds. So do remember this. Now what happened that these winds used to come till this 5 degree, means this northeast trade wind used to come till 5 degree north, while this southeast trade winds used to come till 5 degree south latitude. And the region between this 5 degree north to 5 degree south, this region is known as ITCZ, intertropical convergence zone. This region is a low pressure region. The winds here gets highly heated up, and they becoming warm and getting lighter, they used to move upwards in the upper troposphere. So this region becomes the ITCZ region. So do remember this, from 5 degree north to 5 degree south. This is about ITCZ region. Now what happens, if you have noted it down, I'm moving further. Now what happens in the month of June? In the month of June, the sun is directly overhead. The sun is directly overhead Tropic of Cancer, or 23.5 degree north latitude. So what happens here during this month, that this portion gets highly heated up. This portion gets highly heated up, and it creates a low pressure region in this particular area. So when sun has moved upwards in the northward position, and when sun is directly overhead here, what happened, the entire pressure belts used to move upwards. The entire pressure belt used to move upward, means this ITCZ region, means when the sun was directly overhead equator, we saw that the ITCZ region was from 0 to 5 degree north to 0 to 5 degree south. Now when sun will be here directly overhead Tropic of Cancer, this ITCZ region would be moving at this position. Now this will be the new ITCZ region when during the month of June and July. So this being an ITCZ region, it means this will be a low pressure region. We have seen that ITCZ region is a low pressure region. So what was our ITCZ means region? This was 0 to 5 and 0 to north. It means that what will happen, that 30 the actual 30 degree north, the actual 30 degree north, now this will become the upper limit, or this 5 degree north, it will in turn behave like this 5 degree north latitude region. This 30 degree north will indirectly behave as this 5 degree north region, 5 degree north latitude. And what will happen, that the trade winds which were earlier coming from this region towards, means from 30 degree north towards this equator, they will start coming from here, this region, toward this point, northeast trade wind. Okay, so remember this, that from this, means from northeast trade winds used to come from this region when in the month of June, when the ITCZ has shifted upwards. Now what will happen, that since entire belt has shifted upward, so what will happen, we have seen this southeast trade winds, these will also shift upwards, means from 30 degree south latitude, they will move upwards, and they would be blowing somewhere around this equator, that would be means 5 degree south latitude. This would be behaving something like this 30 degree south latitude. So what will happen, that the winds, means when they will be coming from this direction, southeast trade winds, when they will be coming from this direction, southeast, and once they cross the equator, on crossing equator, their direction will get reversed like this. Why the direction is getting reversed like this? Because of Coriolis force. Because of Coriolis force. Now we know that what is Coriolis force? Coriolis force is change in direction of the wind due to rotation of the earth. Now in the northern hemisphere the winds used to turn right due to Coriolis force, and in the southern hemisphere the winds used to turn leftward due to Coriolis force. So what will happen that these southeast trade winds which were coming from here from southeast, on crossing the equator they will start moving in this direction and they will pretend to be something like this. So we will call them southwest winds. Why southwest? Because now they seem to be coming from southwest. So remember this. And we know that this region is in the month of June, what has happened that this region has already been formed, the ITCZ region has been shifted here, means it is a low pressure region. Now winds are moving from this direction, southwest. So what will be happening that this will intensify the movement of winds towards this ITCZ regions. Okay, so this is the way how south means as per this concept dynamic theory, how how this monsoon is going on. And before this also remember that this term equatorial westerly. So actually what is happening now in this equator region or in this ITCZ region, we already have a wind moving from west to east, that is known as equatorial westerly. Now this equatorial westerly is the main, means as per this flow head, this wind is the main reason for causing the monsoon and rainfall in India, and this is a continuous wind. So during the month of June, what has happened that the entire belt has shifted northwards and this has become the ITCZ region. So what has happened, the equatorial westerlies which were earlier blowing like this in the tropics, now what has happened that due to shift of the ITCZ, these equatorial westerlies started blowing like this, these equatorial westerlies. So these were the main reason for causing monsoon. But what happened that due to when the entire pressure belt shifted upwards, these southeast trade winds also, when they crossed the equator, they became southwest trade winds, and these southwest trade winds, when they combined with equatorial westerlies, they intensified the monsoonal rainfall. So this is how the southwest monsoon used to appear as per dynamic theory. Now we also know that these southeast trade winds, some of these trade winds will be coming from this region and they will be crossing the equator and they will be turning in this manner, in this direction, and become southwest trade wind. But few winds will also come from here, and rather than coming to west side, they will turn their direction from eastern side of India itself. So while this branch was named as Arabian branch, why? Because they have turned to they have turned from Arabian Sea or Arabian region. This branch has been named as Bay of Bengal branch of monsoon. Why Bay of Bengal branch of monsoon? Because they haven't reached the Arabian region, and they have turned from this portion itself, just above the equator, and they have turned to move into India from the Bay of Bengal region. So the southwest monsoon has two branches. One has from Arabian Sea and another is from Bay of Bengal. Now see, both these winds means this wind which is moving from the Bay of Bengal region and this one southwest monsoon, both these winds are moving from ocean toward land surface. So what happens during the month of June to October, when these winds are prominent, they used to move into the land surface of India and used to cause heavy precipitation there. While this Bay of Bengal region used to is responsible for precipitation mainly in the Bengal region, Assam region, parts of Bihar and Odisha. This southeast trade winds is mainly responsible for rainfall in the western sides of the Western Ghats. Why western sides of the Western Ghats? Because these Western Ghats have a good height and winds are unable to pass these mountains or these this Western Ghats. Also, these Western Ghats have very low number of passes, so means it completely in one or other manner it completely blocks the wind. So what happened? The western portion of this Western Ghat used to receive very heavy rainfall, say almost 650 centimeters of annual rainfall, while this eastern portion of this Western Ghat used to remain dry during the month of June to October. Now these southwest trade winds, when they cross this region from the Gujarat and then from Maharashtra region, then they enter the central part of India and northern part of India, and they used to bring precipitation in those parts. Similarly, the West Bengal branch means this also used to move from this region and it used to bring rainfall in this region. And what happened? This southwest monsoon and this means the branch of this southwest monsoon and this Bay of Bengal region, it used to combine here in this region, and this is why this western UP, in this western UP we used to receive heavy rainfall sometimes. Why? Because of collision of this southwest monsoon and Bay of Bengal branch of monsoon. So remember this. Now we see that this southwest monsoon, one branch passes through this Gujarat region and Rajasthan region and it enters here into Jammu Kashmir region. But what happens this branch southwest monsoon, the branch of wind or this branch which is moving from this region Gujarat, Rajasthan to Jammu Kashmir region, it causes very less amount of rainfall here in Rajasthan region. So why it is so? It is because the mountain ranges present here, the Aravalli ranges, these are parallel to this wind's direction. For rainfall to occur, the mountain range should be perpendicular to the wind direction. But what happens here? For example, in Western Ghats, these Western Ghats are like this and winds are moving like this. So what will be this? Winds will be perpendicular to this Western Ghat. So they are responsible for causing rainfall here. But here in case of Aravallis, these Aravallis run like this and winds are also running like this. So what happens? These Aravallis become parallel to this southwest monsoon, and due to Aravallis becoming parallel to southwest monsoon, this southwest monsoon is unable to bring rainfall in this region Rajasthan and northern Gujarat region, and that is why these regions are mainly desertified. A type of desertification is shown in this region. There is one other reason behind this why no rainfall is caused in the northern Gujarat and this western and southern Rajasthan. The other reason is that we have dry winds blowing from this Sindh region into India. Now what happens? That these dry winds and from here moisture laden winds, when these dry winds combine with these moisture laden winds, means it makes these moisture laden winds unable to precipitate here in this region. So the second reason is these dry winds blowing from the Sindh region towards India. That is the second reason why no rainfall is caused in this region. So I hope you people have noted, understood this, the dynamic theory or the equatorial westerly theory for the southwest monsoon. Now similarly what will happen, just this was about southwest monsoon. Now opposite to this what we call as northeast monsoon or retreating. This northeast monsoon is also called as retreating monsoon. So remember this, in case of northeast monsoon what will happen, the winds will start blowing from this region. Why? This ITCZ region or this low pressure region in the month of or from October to December, we know that in the month of December sun used to remain overhead over Tropic of Capricorn. So if sun is directly overhead over Tropic of Capricorn, then this ITCZ region will be formed in that portion, in this southern portion. Means this 30 degree south latitude, this will become the northern portion of this ITCZ region, and above this we will have, this portion will be the ITCZ region. So this will become the low pressure region, and we know that the entire this region will become low pressure region, and we know that winds always blow from high pressure region towards low pressure region. So what will happen, that amount, now this region being not under the direct influence of sun, so this region will become cold enough in comparison to this region, and on becoming cold we know that low temperature we have high pressure. So this region will become a high pressure region, and of course due to high temperature, due to sun being directly overhead in the southern portion, this will become low pressure region and the wind direction will reverse. Why? Due to this ITCZ region being here, the intertropical convergence zones region being here, being very high low pressure region, the wind direction will become like this, and this will become the northeast monsoon. So we have already studied that this northeast monsoon don't used to bring precipitation in the northern and central part of India, but yes, since they move from this Bay of Bengal region, when they enter back into the land surface or in the Indian region, they use, since they have taken the moisture from this Bay of Bengal region, they used to cause rainfall here in Andhra and this Tamil Nadu region, and that is why in the month of December or January we see floods sometimes in Chennai or in the southern Andhra Pradesh region. That is why, because of heavy rainfall due to retreating monsoon or northeast monsoon. So I hope you people have noted it down under dynamic theory or equatorial westerly theory. You must note it down due to this theory is mainly based due to shifting of ITCZ region. If you have noted it down, then we will move to few other theories, because this theory, though it is better than thermal concept, but still it doesn't explain all the phenomena, all the concepts of the monsoon. So there are few other theories, we will be moving to that. Now we will move to our third theory, that is jet stream theory. It is also known as Koteshwaram theory. Why? Because it has been given by a geographer named as Koteshwaram. He was from India. So what does this theory says? This theory says that the south west monsoon or summer monsoon is result of tropical easterly jet and north east monsoon or winter monsoon is result of subtropical westerly jet. Write down this. This is as per the jet stream theory or the Koteshwaram theory. This theory says that the summer monsoon in India or the southwest monsoon, means which used to run from this manner from southwest to northeast direction, that is result of the tropical easterly jet, and the northeast monsoon means from northeast towards southwest. This northeast monsoon, it is, or the winter monsoon, is a result of subtropical westerly jet. So here you are seeing these two terms, tropical easterly jet and subtropical westerly jet. So we will be understanding this theory also and this also. So before this, we should know that what do we mean by jet stream. So actually jet stream are means, unlike the normal surface winds which we used to observe and which we used to see, these jet streams are upper surface, means upper layer winds, or up in the they used to blow 9 to 12 kilometers above the earth's surface or in the upper troposphere region. So these jet streams are upper atmospheric wind, upper atmospheric winds which used to blow from 9 to 12 kilometers above the surface, above the earth's surface, and their speed is very high, say 200 to 300 kilometer per hour, and their width also ranges from 100 to 300 kilometer in length. So this is the definition for jet stream. Do remember, the jet stream are not the surface winds, but they are upper atmospheric winds which used to blow 9 to 12 kilometers in the upper atmosphere. They generally blow from west to east. Remember this. This is their main direction, but it is not that all the jet streams used to blow from west to east. You will see here. These jet streams are mainly of two types, means permanent and temporary. Now these permanent, we see here we have this subtropical westerly jet. Now the term this subtropical westerly jet means this is a permanent jet stream. Example of permanent jet stream: subtropical westerly jet stream. Permanent here means this used to blow throughout the year, and temporary means it used to get created over a particular time period. And now here we have another term. This is tropical easterly jet. This is an example of temporary jet stream, because this will be getting created over a particular time period. We will be seeing this tropical easterly jet. So I think you people have noted it down. Permanent and temporary jet. This is subtropical westerly jet stream and tropical easterly jet stream. Now we will see that how this theory goes. Now what happens, that this subtropical westerly jet stream, this is a permanent jet stream. This is a permanent jet stream, and it blows from west to east, generally in the latitudes of 50 degree to 60 degree north. Means it is much above India, over China, or in the parts of Russia. This is a permanent jet stream which then blows from west to east, much above India, in the China and in the Russia region. But what happens, that their movement from west to east over China and Russia, this is in the month of June to October. So what happens, that the same jet streams in the month from October to December, when the sun moves, means the apparent position of the sun moves downwards, and in the month of December when it is over Tropic of Capricorn. Now we know that in the month of December when the sun apparent position of the sun is over Tropic of Capricorn, the entire pressure belt used to shift downwards. Now when the entire pressure belt used to shift downwards, what happened? The position of this subtropical westerly jet stream, which is a permanent jet stream, also used to shift downwards, and which was earlier blowing here in this region 50° north to 60° north. It starts blowing, the same starts blowing in the month of October, December. It starts blowing in the range of 30 to 40° north latitude, in the same direction, west to east. Remember this. Now what happens? So we have seen that in the month of October and December, where it used to be over this region 30° north to 40° north, and this will be somewhere around here. When it enters India, it enters in this region. So what happens? That these are upper atmospheric winds. When these enter India here in this region, so here this portion is Tibet region. Now we know that the Tibet region, this region is means at much higher altitude compared to other region, and we know that being at higher altitude, this region used to get more heat than the surrounding region, and due to getting more heated, the surface air here gets warmed up and it should rise upwards. But what happened that during the month of this October to December, since the subtropical jet streams, the upper atmospheric winds are over here, so what happens? The upliftment of the surface wind over Tibet, it is not possible. Why? Because due to high pressure region over this Tibet region, and means due to this subtropical westerly jet streams above this, the upliftment of the winds here is not possible during this October to December month, and high pressure region is formed over the surface over this region, and that is why what happens that this also becomes one of the reason for this northeast monsoon during this month October to December. But what happens that in the month of June to October, see here what in the definition what we have written is, in the winter months the subtropical, in the winter month the result of subtropical westerly jet. So in the winter months means, what do you mean by October to December month? We have the northeast monsoon. So this is how we are seeing that in the winter months, in the October December month, these subtropical jet streams, they used to be running from here to here, and over the Tibet they used to maintain high pressure region, and we know that here in this region we have low pressure region. So what happened? These used to pull winds from this region, high pressure region towards low pressure region, and this used to result in this northeast monsoon, this subtropical westerly jet streams. So we have seen the second portion. Now we will move to first portion. The summer monsoon are a result of tropical easterly jet streams. How these are result of tropical easterly jet streams? What happens in summer means in the month of June, this subtropical jet stream, when we know that the sun apparent means the apparent position of the sun is over Tropic of Cancer, means sun has moved upwards, northwards. So what happens? The entire pressure belt will shift northward. So if the entire pressure belt will shift means northward, this subtropical westerly jet stream, which in the month of October, November, which was over this 30 to 40° north latitude, means in the October to December, this was over 30 to 40° north latitude. In the month of June to October, the same will be moving upwards, and this subtropical jet stream, subtropical westerly jet stream will be in this latitude. Now when this subtropical jet stream will also move upward, means due to shifting of the pressure belts northward, what happens is that this region, means the region over Tibet, this becomes free of this subtropical, this region becomes free of this subtropical westerly jet stream. So earlier what happened, that due to this Tibet region getting much higher heat than the surrounding region, the air was not able to uplift. But now since these subtropical westerly jet streams are not present here, this Tibet region in the month of June to October getting much higher heated in compared to surrounding region. The winds here, what will they do? They will become heated, they will move upwards, and after reaching a particular height, say 8 to 10 kilometers, what will they do? They will form a high pressure in that region, and what will be, since that will be a high pressure region in the upper atmosphere or anticyclonic condition, that winds will be moving, wind will be moving in the southwest direction as upper atmospheric wind. So do remember that these winds will be moving as upper atmospheric wind, the winds which are rising here in Tibet region, winds rising in the Tibet region, they will be moving as upper atmospheric wind, and they will descend down here somewhere in the Indian Ocean, below the somewhere in the Indian Ocean here. And what will they do? The southwest monsoon, means these winds, these southeast winds which earlier used to work, which were coming from this side, and on crossing equator, when they were turning like this, in the southeast trade winds, which got converted into southwest trade winds, what will they do? These means upper atmospheric winds coming from over Tibet, when they will descend down here in the Indian Ocean, what they will do? They will push this southwest trade winds. Now since they are pushing this southwest trade winds towards India, so Koteshwaram told that the southwest monsoon or the summer monsoon, that is in the month of June to October, these are result of tropical easterly jet, means since they are coming from east, these are named as tropical easterly jet stream, and they are temporary. Why they are temporary? Because they are not blowing, these winds are not blowing throughout the year, but these are formed over a particular season, that is over the month of June to October. These are not permanent, and these are formed only over June to October. So these tropical easterly is an upper atmospheric wind which used to move from Tibet and descend down in around say 10 to 20 degrees south latitude, and then this used to push the southwest monsoon towards India, and this result in this tropical easterly jet streams are the main reason behind this southwest monsoon. So I hope you people are clear with this definition of jet stream theory or the Koteshwaram theory, how this subtropical westerly jet stream and this tropical easterly jet stream result in northeast monsoon and southwest monsoon in India. Now we will move to another topic, or the fourth theory. Now we will study about the impact of Walker circulation, El Nino and La Nina on Indian monsoon. See, we have seen in the jet stream theory or the Koteshwaram theory the impact of tropical easterly jet stream and subtropical westerly jet stream on the Indian monsoon. We have seen that tropical easterly jet stream, it used to boost the northeast monsoon, and the subtropical westerly jet stream this tropical easterly jet stream used to boost south west monsoon, while the subtropical westerly jet stream used to boost north east monsoon. So you can note down like this, because in the starting of this lecture we have defined the headings which we are covering under this topic. So there we have written that we will study the impact of tropical easterly jet stream and subtropical westerly jet stream on Indian monsoon. So this topic was covered under that jet stream theory itself, that tropical easterly jet streams will boost the southwest monsoon in India, while the subtropical westerly jet stream will boost the northeast monsoon in India. Now we will be moving to Walker circulation, and we will see the impact of El Nino and La Nina on Indian monsoon. So first write down the definition for Walker circulation, then I will explain it to you. What do we mean by Walker circulation? Actually, this term was given by Gilbert Walker. He was a geographer. So based on his name, this term has been given Walker circulation. What is the definition for Walker circulation? Walker circulation, it is the relation between atmospheric air circulation and temperature of Western Pacific and Eastern Pacific in tropical regions. So this is the definition for Walker circulation. What is Walker circulation? It is the relation between atmospheric air circulation and temperature of Western Pacific and Eastern Pacific in the tropical region. So see here I have drawn a rough diagram. This is South America, and this one is here Australia, and here we have Southeast Asia. So in between this South America and here this Australia and Southeast Asia, we have Pacific Ocean. Now if this region is a Pacific Ocean, then we can see that what will be the western part of Pacific Ocean? Of course, this region. This will be Western Pacific Ocean. And what will be this? This will be Eastern Pacific Ocean. So this Eastern Pacific Ocean will be on the western part of South America, and Western Pacific Ocean will be on the eastern part of Australia. Do remember this? Now, as per Walker circulation, what we have to see is that temperature of Western Pacific and Eastern Pacific, means temperature here and temperature here, and the relation between the atmospheric circulation, air circulation means the movement of air from here to here or from here to here, as surface winds also, as well as upper atmospheric winds also. So this is what used to define Walker circulation. So what happens is that in general condition, see, also this part lies in the tropical. Since we have written here tropical region, it means that this Pacific Ocean is not only spread in the tropical region. This means this Pacific Ocean is spread much beyond above the tropical region also. But we have to study only about this tropical region, because as per Walker's circulation definition. So imagine that this portion lies in the tropical region. So what happens, we know that the tropical region being directly under the influence of sun, directly getting heated through the sun, it remains warm comparison to other regions, or the temperate region or the frigid region. So what happens, the water here also used to remain warm water. So what happens in general conditions, since earth is rotating from west to east, this warm water used to move in this manner, and generally this warm water used to get collected in this region. Of course, you know that if warm water moves as surface water in this manner, in this direction, and gets collected over here in the on the eastern coast of Australia, what we in this condition, we know that the water which will be in order to replace this region, means warm water is moving from this region, then in order to replace this region, cold water from deep inside the sea or deep inside the ocean will move here and will upwell here on the Eastern Pacific Ocean, or on the west coast of South America. I hope you people are understanding. If the surface warm water under the influence of trade winds, or due to rotation of the earth from west to east, or under the influence of trade winds, the warm surface water is moving toward the eastern coast of Australia, then in order to occupy this place, or in order to complete this circle, the cold deep ocean water will move in this direction. It will upwell here over the Eastern Pacific Ocean. So this is the general condition. Now this general condition is only known as La Nina. La Nina, actually it has been given in this term has been given. Why? Because this general condition, only when it gets intensified, means large amount of cold water used to upwell here, and means maximum amount of warm water gets to be deposited here in this region, then this is known as La Nina. Now this La Nina is considered good for Indian monsoon. So since we have to study the impact of La Nina and El Nino on Indian monsoon, so this La Nina used to be good for Indian monsoon. It is considered good for Indian monsoon. Now why it is considered good? See, what will happen, that in the month of see here that how this La Nina used to be considered good for Indian monsoon. So you have already seen the definition of La Nina. What is La Nina? That the intensification of the general condition of the Pacific Ocean, means the Western Pacific Ocean and the Eastern Pacific Ocean. Whatever the general condition is there in terms of temperature and air circulation, if that condition only gets intensified, then that is known as La Nina, and that La Nina is considered good for Indian monsoon. We will be seeing how it is considered good for Indian monsoon. So under La Nina, what is happening is that the cold deep ocean water of the Pacific Ocean, it is getting upwelled here on the west coast of South America, and the warm surface water, it is getting accumulated in the eastern coast of Australia and over here in the Southeast Asia region. So we know that means low temperature here over this part of the ocean will have high pressure above it. We have seen this concept earlier. And here means high temperature over ocean water in this region will have low pressure above it. Also we know that winds move from a high pressure to low pressure region. So what will, under this La Nina condition, what will it happen? That the winds will start moving from this high pressure region to this low pressure region. And what happens in the extreme La Nina case, this warm water used to means which were earlier used to intensified in general condition over the east coast of Australia and over this part of Southeast Asia. The warm water used to get accumulated over in this region also. So what happened that this means winds which used to blow from high pressure region towards this low pressure region, this used to extend further. Now in the month of June, when the southeast trade winds, these southeast trade winds are moving from southeast towards moving from southeast towards northwest, and on crossing equator it is getting converted into southwest wind. What will happen that these winds which are coming from the eastern Pacific Ocean, means which are coming from the eastern Pacific Ocean from high pressure region toward this low pressure region, these will intensify these southeast winds which are already blowing in the same direction. Means southeast trade winds which are already blowing in this direction, this extra additional wind which will be coming from this Pacific Ocean in this direction, in the same direction, this will intensify these southeast trade winds. And since these southeast trade winds only get converted into this these southeast trade winds get converted into southwest monsoon, so due to intensification of these winds, the condition of monsoon in India will also intensify, or it will become good. So I hope you are clear with this concept that how this La Nina is means behaving in a good manner for Indian monsoon. Now we will see about El Nino, the opposite of La Nina. What will happen in case of El Nino? See, this is Southeast Asia portion, this one is Australia, this one is South America, and the region between this is in Pacific Ocean. This one is Western Pacific Ocean and this one is Eastern Pacific Ocean. So, and this is the tropical region of Pacific Ocean and we know that what happens in general condition, means the warm waters of the tropical Pacific Ocean used to move here, but what happens means in abnormal conditions, due to weakening of the trade winds, the warm water which earlier used to move and get accumulated here in this region, that warm water will not be moving here in this region, and rather than getting accumulated over in this region, that warm water will move and get accumulated over this region, in the region of this western South America or the western coast of South America. And this region, means this Western Pacific Ocean, will become a center for cold water. How it will become a center? Because if the warm waters will get accumulated here, then of course the deep ocean water will move in order to complete this cycle and it will get accumulated, or it will get upwelled here in this eastern coast of Australia. Now this is the condition of El Nino. El Nino, just opposite of La Nina. So in this condition, what it happens, the earlier wind which was blowing from this region, means from a higher pressure region to lower pressure region, now it will get reversed and it will start blowing in this form. Why? Because cold water remaining here, high pressure region will be formed here and low pressure region will be formed in this point, at this point. So what will happen, also if this cold water gets stretched to further in this region, the winds will start blowing from here in this region in opposite direction. So in case of El Nino, what will happen, since winds are blowing here in this direction and southeast winds used to blow in this direction, in case of El Nino, this condition will weaken the southeast trade wind. What will happen? It will weaken southeast trade winds. Now we are seeing that this wind is blowing just opposite to southeast trade winds, so it will reduce the speed of southeast trade winds. And since it weakens the southeast trade wind, and we know that southeast trade winds are the winds responsible for monsoon in India, so monsoon in India will also become weak. So this is how this El Nino used to, means how this Walker circulation, El Nino and La Nina used to impact Indian monsoon. So in case of in El Nino, you can write here, if El Nino is there, then Indian monsoon used to decrease. You can put it into box. Similarly for La Nina, if La Nina condition is there, then Indian monsoon used to increase. I hope you people have understood. It is nothing but just the air circulation pattern or movement of the air circulation, and how that air circulation is impacting the southeast trade winds. If the air circulation in case of La Nina is favoring southeast trade winds or boosting southeast trade winds, then we have good monsoon. And in case of El Nino, when the wind direction is just opposite to the southeast trade winds, then we see that since southeast trade winds are getting weak in case of El Nino, then El Nino is impacting negatively on Indian monsoon. If you are clear with this, then we will be moving to our next topic, that is impact of I think only Somalian jet is left, because we have already seen the impact of El Nino, La Nina, Walker circulation. Then we have seen about tropical easterly jet. We have seen the impact of Tibet region. Then subtropical westerly jet. Means this tropical easterly, subtropical jet and westerly jet streams both are related with this Tibet only. So we have seen the impact of all these. Now we are left with only impact of Somalian jet. So we will be seeing it here, how the Somalian jet used to impact Indian monsoon. See, Somalian jet are also temporary jet stream. Temporary jet stream. See, we have a mascarene high pressure region. Mascarene high pressure region, which is near about 20 degree to 30 degree south latitude. Okay, so in the month of June, when the sun is directly overhead here over Tropic of Cancer, and this region means southern portion is not under the direct influence of sun, then on the coast of, means near to Madagascar here in Africa, we have a region known as Mascarene, which is developed as a high pressure region. Why? Because this region becomes very cold, and we know that if low temperature, then high pressure region above it. So, and where is Somalia? Somalia, we know it is on the eastern coast of Africa. Where is Somalia? Somalia is on the eastern coast of Africa. See, if I draw a rough diagram to explain it to you, consider this as Africa, and this is here Madagascar, and here we have Mascarene high. What we have written here as Mascarene high pressure region. This has 20 to 30 degree south latitude. This is this region, and here we have Somalia on the eastern coast of Africa, and this Somalia is having a latitude of almost 5 degree north latitude. Equator will be somewhere here, 0 degree equator. So what happens, we know that during the month of June, when in the month of June and July, when this ITCZ region is above here or the low pressure region is above here, in this region, low pressure region is there. So what happened? And here we have high pressure region. Why? Because this masculine high. Why? Because this region is not under the direct influence of sun, and due to cold or low temperature, we have very high pressure region over this. But we know that since this region means 5 degree north, this falls above equator, and this will be more under the influence of sun. So this will be a low pressure region. So what will happen? We know that winds used to move from high pressure to low pressure region. So what will be going on? This from masculine high pressure region, winds will be moving towards this Somalian low pressure region. Now what will happen? This being a low pressure region and winds moving towards this, the winds will move upwards. Okay, winds will rise on getting warm, and on getting warm they will rise, and since here a low pressure or this trough region has been already created, monsoon trough, low pressure has been already created during the month of June, July. So on winds getting, these winds on rising, these will move in this manner in this region. Now the second thing about this Somalian jet. What is this Somalian jet? This is a temporary jet stream, and it moves only 1 to 2 kilometers above the Earth's surface. Means unlike other jet streams which used to move 9 to 12 kilometers above the surface, these Somalian jet streams move only 1 to 2 kilometers above the surface. So what will happen? These Somalian jet streams, they will be moving from this region, from the coast of this Somalia towards India, and what will be they doing? They will be boosting the southwest trade winds, and therefore these will become, means this will be becoming helpful, or it will becoming helpful, or this will increase the Indian monsoon or rainfall through Indian monsoon. So we have seen that how means different phenomena have impacted Indian monsoon. So this was about Somalian jet streams. About Tibet we have already seen. Means if low pressure region is created in this Tibet region, then the winds here rise. The same winds on rising up to a tropopause, they used to move towards the southwest region as upper atmospheric wind. The same wind used to descend in this portion, and when the same winds used to descend, they move as surface wind towards, means northeast or towards India, and they used to boost monsoon. So what happens if for the some or the other reason this low pressure region is not created in this Tibet region? Why? Sometimes it may happen that this region may get accumulated by the snow. If this region get accumulated by the snow or ice cover due to some or the other reason, and this ice cover snow remains here in the even in the month of May, June and July, then what happens? The low pressure region will not be formed in this portion. Now if low pressure region will not be formed in this region, then what will happen? The winds will not rise up. When these winds will not rise up, they will not descend here in the southwest portion, and they will not be moving as surface wind, and they will not be boosting the southwest trade winds. Therefore what will happen? The monsoon in India will become weak. So what will you write about, as you have written about this Somalian jet boost Indian monsoon? For Tibet you can write low pressure increases in Tibet, then it increases Indian monsoon. If high pressure increases in the Tibet region, then it leads to poor Indian monsoon. You can note down all this in brackets, so you know the end result of all these phenomena and their impacts on the monsoon. I will be writing it down as a summary here. once I complete with the Indian Ocean dipole, I will be writing down as a summary. You can note down it as a summary. So wherever in the exam if you are asked, you can draw that particular flowchart, and that will help you in fetching good marks. We have Indian Ocean dipole IOD and its impact on Indian monsoon. So we will see that first, what do you mean by Indian Ocean dipole? Write down with definition. Indian Ocean dipole or IOD is the relation between sea surface temperature or SST, sea surface temperature in Western Indian Ocean and Eastern Indian Ocean with respect to atmospheric circulation between them. So this is the definition for Indian Ocean dipole. It is the relation between the sea surface temperature of the Western Indian Ocean. This portion will be Western Indian Ocean, and here it will be Eastern Indian Ocean. So we see what is IOD, Indian Ocean dipole. It is the relation between the sea surface temperature SST in the Western Indian Ocean and Eastern Indian Ocean, Western Indian and Eastern Indian Ocean with respect to atmospheric circulation between them. Atmospheric circulation means movement of surface air and upper atmospheric air between these two, means between Eastern Indian Ocean and Western Indian Ocean. So how will this impact the monsoon? See, we have two parts here. One is positive phase of Indian Ocean dipole, and another is negative phase of Indian Ocean dipole. When it is called positive phase, when this Western Indian Ocean has warm waters and this one has cold water. So when it is called positive phase, when Western Indian Ocean has warm waters over surface, warm water over surface, and Eastern Indian Ocean has cold water over surface. So we know that if Eastern Indian Ocean, here it will be having cold water over the surface, then we will have high pressure region here, and if we have warm water over this surface, then what we will have? Low pressure region in this region in this area. And this is said as positive phase. Why? Because this is the phase, means this positive phase used to boost monsoon, Indian monsoon. That is why it is known as positive phase, because if winds will be moving from here, cold, from this means high pressure region to this region, now what will happen? This region being warm will help. This region being warm will help the winds above it. The winds above it to have good moisture content. We know that the moisture content in winds used to depend upon the temperature of the water below it. So if this portion is the warm portion, then of course we know that these south-west winds which are blowing here, now this surface winds means these winds will be blowing from here. They will be firstly boosting this southwest winds. Next, this region being warm will have the southwest winds to carry more amount of moisture with them while they will be entering India. So this is known as positive phase or warm. This positive phase, it means warm Western Indian Ocean and cold Eastern Indian Ocean. On the other hand, we have negative phase of IOD. In case of negative phase, what will happen? The condition just reverses. The Western Indian Ocean, it becomes cold, while the Eastern Indian Ocean, it becomes warm. So what happens? The condition reverses. Here it becomes warm and this region becomes cold, means this Western Indian Ocean, and the winds, firstly winds blow opposite. So these winds used to weaken the southeast trade winds, SETW, means these winds which used to blow from this region, because this region becomes cold and this region becomes warm, so this region becomes high pressure, this becomes low pressure. Winds start moving from here to here in opposite direction. Winds, when will be moving here in opposite direction, they will be weakening southeast trade winds. Next, what happens, that this region, when it becomes cold, what will happen? It will reduce the moisture content of the winds present above this region. Means the southwest trade winds which are present above this region, they will have lesser moisture content, and when they will be moving into the India, they will be causing lesser amount of precipitation. So do remember this, that the positive phase of Indian Ocean, that used to boost the Indian monsoon, while the negative phase of this IOD used to decrease Indian monsoon. So I can write here a positive phase of IOD increases Indian monsoon, while negative phase of IOD decreases Indian monsoon. So you can again put this under bracket, you can write this. So with this we come to end of IOD also. Now actually we have left one thing, that while we were studying Walker circulation, I missed to mention about this southern oscillation index. So you can, under that heading, Walker circulation, you can write about southern oscillation index, SOI. Now this is a means index. Southern oscillation index is used to measure the intensity of Walker circulation. What is southern oscillation index? It is used to measure the intensity of Walker circulation. Now how this measures, means how it impacts. Now what happens, that if the southern oscillation index measured is highly positive, or it is having positive value, then this leads to means La Nina condition. Okay, and when it leads to La Nina condition, it will boost Indian monsoon. If this southern oscillation index is having negative value, then this will lead to El Nino, and we know that El Nino used to reduce Indian monsoon. So you can again put this under bracket. Now I am going to make a flow chart here, means you can first you note down this. Now I will be making a flow chart. You can make this that flow chart in the similar manner, and wherever required in the subjective answers, you can mark you can draw that flow chart. Okay, if you have written this, I am drawing the flow chart for you. See, impact on Indian monsoon. How different events used to impact Indian monsoon, you can write it. Okay, so what we will be doing, first we will start with the different first let us start with this IOD itself, Indian Ocean dipole. You can write is positive phase, positive IOD used to boost Indian monsoon. Then again here you can write it as negative IOD used to decrease Indian monsoon. Next you can write Walker circulation or southern oscillation index. Now how this used to means impact Indian monsoon, then you can write here that positive value of southern oscillation index results in La Nina and it boosts Indian monsoon. Then similarly you can add here that negative value of southern oscillation index used to boost El Nino and then it used to reduce the intensity of Indian monsoon IM. So this was about Walker circulation IOD. Next you can move to subtropical westerly jet stream. So we have seen that how subtropical westerly jet stream used to impact Indian monsoon. It used to boost or increase north east monsoon. Subtropical westerly jet stream used to boost northeast monsoon. Do remember, it is not the southwest monsoon, while the tropical easterly jet stream, these used to boost southwest monsoon. Now if you are done with this, then we will be moving to next, that is Somalian jet. How Somalian jet used to impact? It used to increase or boost the Indian monsoon. So I think we are done with this. Anything left? IOD means Walker circulation, means La Nina, El Nino. Then we have subtropical westerly jet stream, tropical easterly jet stream, Somalian jet, then Tibet region. Impact Tibet region. Now you can write here low pressure in Tibet region used to boost southwest monsoon, while if high pressure in the Tibet region during the month of, here you can write, mention the June, July, if it is high pressure region, then it reduces southwest monsoon. Similarly here you can write, if it is high pressure region in the Tibet area, then it boosts northeast monsoon when in the month of December. I hope you people have noted it down. Note down this final flow chart. You can use this in any of the subjective examination where the question is asked based on this topic. So if you are done with this, if you people have noted down this, then we will be moving to our next heading. The next heading we had was factors affecting Indian monsoon. So you can note it down. These are the 9 factors. We have already discussed about these. means you, if you are asked that directly 5 mark question in the 5 mark question or 10 mark question, that please explain the factors which affect the Indian monsoon, then you can write these. First one is trade winds, both northeast and southeast trade winds. We have seen how these trade winds used to impact the Indian monsoon. Next is Coriolis force. We know that how Coriolis force used to impact Indian monsoon, because that is responsible for converting the southeast trade winds into southwest trade winds. And again, in the reverse case, then we have ITCZ region. We know that how the shifting of the ITCZ region is responsible for Indian monsoon and how this used to impact Indian monsoon. Then we have pressure conditions over the Tibetan plateau. We have seen that how the high pressure condition over here and low pressure condition over here or the Tibet, how it used to impact the jet streams and how it used to impact the Indian monsoon. Next we have subtropical westerly jet streams. We know that we have seen the impact of subtropical westerly jet streams in the month of June and in the month of December over the Indian monsoon. Next is tropical easterly jet stream. We have seen it is a temporary jet stream and it used to form mainly in the month of June over the Tibetan plateau. So how this used to impact the Indian monsoon. Next we have sea surface temperature over Western and Indian Ocean. Western Indian Ocean. We have seen how the positive phase of IOD and negative phase of IOD used to impact the Indian monsoon. Next we have pressure conditions over east coast of Somalia. The pressure condition over east coast of Somalia means if the pressure condition there is low, then it will boost the Somalian jet stream, and we have seen that Somalian jet stream is helpful for Indian monsoon. If the pressure condition on the east coast of Somalia becomes high, means the pressure remains high there, then Somalian jet streams will be very poor or they will not be into existence, because these are also temporary jet streams which are formed based on the pressure conditions on the eastern coast of Somalia. So we have seen that how this pressure conditions on the eastern coast of Somalia is impacting the Indian monsoon, or how the Somalian jet is impacting the Indian monsoon. Next we have temperature and pressure condition in the western and eastern Pacific Ocean. So of course we have seen the events of La Nina and El Nino, which are result of the pressure and temperature condition in the western and Indian Ocean, western and eastern Pacific Ocean, and how this used to impact the Indian monsoon. So I hope if you people have noted it down, then we will be moving to our next heading under this, that is distribution of monsoonal rainfall in India. And next we move to distribution of rainfall in India. See, average rainfall in India is 125 centimeter. Now in India we have rainfall due to various phenomena, but 75% of the rainfall in India is due to southwest monsoon. You can note down this, you can draw this flow chart. When you are asked about distribution of rainfall in India, you can draw this flow chart. Means average rainfall in India is 125 centimeter, out of which 75% is through southwest monsoon. Then we have 13% through northeast monsoon, then 10% through pre-monsoon, and 2% through western disturbances. So note down this, the maximum amount of rainfall is through southwest monsoon. Now if I talk about this pre-monsoon, though I have not explained it to you, I will be explaining it here. See, pre-monsoon is nothing but rainfall in the month of April and May. See what happens, we know that monsoon used to come in the month of June, but pre-monsoon means just before monsoon. So in the month of April and May, the rainfall in India is known as pre-monsoonal rainfall. And why this is why this rainfall occurs? This is mainly cyclonic rainfall. Means cyclonic rainfall. Now what happens, we know that what happens in the month of April, May and June, the apparent movement of the sun is northwards, and in the month of June it comes over Tropic of Cancer here. But what will happen, that while the apparent movement of the sun towards north in the month of April and May, the temperature here in the Bay of Bengal region, or the sea surface temperature in the Bay of Bengal region, this will rise, and it will move to about 27 degrees centigrade. And we have studied in the tropical cyclones topic that if sea surface temperature is above 27 degrees centigrade, then this leads to generation of tropical cyclones. So what happened that in the month of April and May, large number of tropical cyclones are formed. Tropical cyclones are formed in this Bay of Bengal region, and these, we know that tropical cyclone used to move from east to west, means this is the direction from tropical cyclones, from from east to west. And these tropical cyclones used to bring rainfall in this West Bengal region, Odisha region, Bihar region, Jharkhand region, and also in the if the cyclone reaches on this coast, it also used to bring rainfall in this Karnataka and Kerala region. Okay, so what happened, this pre-monsoonal rainfall or this pre-monsoonal event is known by different local names in these states. So you can draw this diagram, or you can draw this flowchart, and you can write this, because in objective type questions you are directly asked these names. For example, they may ask you that pre-monsoonal rainfall is known as nor'wester in which state. So it is actually known as nor'wester in the eastern states of West Bengal, Odisha and Assam. Then Kal Baisakhi means pre-monsoonal rainfall is known as Kal Baisakhi in local language. In which state? It is known as in West Bengal. Then remember this cherry blossom. This is very important. Cherry blossom. Pre-monsoonal rainfall in the Karnataka and Kerala region is known as cherry blossom. Then in other part of southern India, it is also known as mango showers, because this pre-monsoonal rainfall is very helpful for ripening of the mangoes. So that is why it is known as mango showers. And finally we have here Bardo Chila in Assam. In Assam region, the pre-monsoonal rainfall is known as Bardo Chila. So I hope you people have noted it down, the distribution of rainfall in India, and also understood the pre-monsoonal rainfall, and you might have noted down these local names and region for pre-monsoonal rainfall. If you have done this, we will move to our next heading, that is features of Indian monsoon. In the distribution of rainfall in India, you need to mark on this rough sketch of India. You can mark it here that all the regions don't have similar amount of rainfall. See, few regions, for example, this western side of Western Ghat, this region receives more than 200 centimeter of rainfall. Then we have this Andaman and Nicobar Islands, which receive more than 200 centimeter of rainfall. Then we have this northeastern parts of northeastern region, mainly especially here the Garo, Khasi and Jaintia hills. You might have heard the name of Monsoon Ram. This Monsoon Ram is a place on these Khasi hills, and this is said to receive the maximum rainfall in India, and this receives almost 1100 centimeter of annual rainfall, this Monsoon Ram. So this means overall this portion, this northeast portion, or in the parts of this Manipur, Meghalaya, Mizoram, this region receives more than 200 centimeter of rainfall. Similarly here in few parts of Western Ghats, while we receive more than 650 centimeter of rainfall, the average rainfall in this western part of the Western Ghats is almost 200 centimeter of rainfall. Also we have few dry regions in India. One is this Ladakh region and parts of Kashmir, Jammu and Kashmir. Why this region remains dry? Because monsoon winds doesn't reach here, neither the eastern branch nor the western branch of monsoon. And also this western Rajasthan and northern Gujarat, this portion also used to remain dry, or generally this region also used to contain get very less precipitation. Why this region used to get less precipitation? I have already explained it to you in this video itself, that the Aravalli ranges here, the monsoon winds used to blow parallel to the Aravalli ranges, and that is why they don't cause rainfall here. For winds to cause rainfall, the mountains should be perpendicular in the direction of the wind, then only it leads to upliftment of the wind, and then cooling of the wind, and then release of latent heat of condensation, and then precipitation. So since that is not happening here, so this region also used to remain dry. The other part of the India receives on an average rainfall that would be near about from 70 centimeters to say near about 150 centimeters, from 70 to 150 centimeters. This is the rainfall condition in other parts of India. So you mainly need to note down the maximum rainfall places and the dry places, and other places you can count in under average rainfall conditions. So moving to our next topic, that is features of Indian monsoon. So these are the 5 features which you can note down. First one is that the Indian monsoon depends upon the topography of a place. You can write here Indian monsoon depends upon the topography of a place. How it depends upon the topography of a place? See, for example, here in the Western Ghat region, mountains are present, Western Ghats have good height, so topography here used to determine the rainfall. How it used to determine? When the southwest trade winds used to come here or move towards Western Ghat, they used to get uplifted when they strike this Western Ghat, they used to get uplifted, and these moisture containing winds, when they get uplifted, they cool down. They release latent heat of condensation, and they precipitate on this side of the Western Ghats. So this is, for example, here. Similarly, we have seen topography here, means when the winds run parallel to here, means Aravalli ranges, these winds are unable to cause rainfall here. If this Aravalli ranges would have been in this manner, means perpendicular to the southwest monsoon, then rainfall must have been here also. See topography again here in the Garo, Khasi and Jaintia hills. These means hilly region is again leading to higher rainfall in this region. For example, here in the plains region we have an average rainfall. So this is how the topography of a place determines the rainfall or the monsoonal rainfall. Next we have rainfall varies from distance from the sea. Of course, we have seen that when this moisture laden winds, when they will reach the coast area, they will try to precipitate or bring maximum rainfall there only. Means they will try to deposit maximum moisture content on the coastal region itself. So when they reach here in the central part or in the hinterland, so what happens? The amount of moisture content in the air used to reduces, as maximum rainfall used to be on the coastal area itself, or the region where the winds used to strike the land surface. So this is the second thing, means rainfall varies from the distance from the sea. Means as the distance increases, then rainfall decreases. Distance from the sea increases, then rainfall decreases. Means here we will have lesser rainfall and compared to this region or coastal region. Third feature is burst of monsoon. Now what do we mean by burst of monsoon? See what happened in the month of June when ITCZ region used to shift here in the near the Tropic of Cancer. So what happens? Monsoon trough used to be formed here. Now what is monsoon trough? Trough is a region of low pressure. So monsoon trough here means it is a region of low pressure where winds used to converge from this region, means this northeast trade winds which has shifted along with the shift of the pressure belts, and the southeast trade winds, or we can say that this is a region where the winds used to converge. So due to shifting of this monsoon trough here, what happens? The southwest trade winds which used to blow in this manner, due to shifting of the monsoon trough here, it increases the intensity of these winds. Means it used to pull this low pressure region, it used to pull these winds quickly towards the inland or toward the hinterland of India. Now this quick pushing of these southwest trade winds by the monsoon trough into the India, that is known as burst of monsoon, and it is characterized by severe thunderstorms and heavy rainfall, especially in the month of June. So I hope you must have understood the burst of monsoon. It is the pulling of the southwest monsoon quickly in the month of June due to monsoonal trough formed in the northern India region or above the Tropic of Cancer region. So this is known as burst of monsoon. Fourth feature of monsoon is break or August break. See what happens in the month of August. Monsoon used to come in the month of June, and it used to rain in the month of June, July. But what happens in the month of August for 1 week or say 2 weeks? Sometimes most of the India used to remain, means most of the India don't used to witness the monsoonal rainfall. It is for 1 week or 2 weeks. This 1 or 2 week is known as August break, means break in the monsoon. And why it used to happen? This used to happen, why? Because this southwest trade winds which used to blow from southwest towards Indian over this land surface, Indian land surface, sometimes these southwest trade winds used to change their direction in this manner, and they start blowing parallel to Indian coast, and rather than entering India, they enter Pakistan and this region. So if these moisture laden winds, if they are not entering India and they start blowing parallel to the coastal surface, of course they won't be causing rainfall in this region, and this generally happens in the month of August. So what happens, that in the month of August we used to observe this phenomena or this part of monsoon, that is break or August break. Finally, we have gradual retreat. We have seen that the burst of the monsoon, means the arrival of the monsoon is very quick due to this monsoon trough, while its retrieval or retreat is gradual. Means after the month of October, this monsoon is slowly used to retreat in the form of northeast monsoon, or it used to move back, and this movement, northeast monsoon, is characterized by almost no rainfall in this region, no thunderstorms, and it used to gradually move, and it used to bring certain amount of rainfall here in the southern India, in parts of Tamil Nadu and Andhra Pradesh. So this is the fifth important feature of Indian monsoon. I hope you people have noted it down, all the 5 features, and also you might have understood the features of Indian monsoon and distribution of rainfall in India. Now with this, finally we will be moving to the last heading under this topic, that is significance of Indian monsoon. Next we move to significance of Indian monsoon. Significance of Indian monsoon, that how Indian monsoon is important for us. The first significance is that it is the main source of water for agriculture. We know that almost 60% of agriculture in India, 60% of agriculture in India is rain-fed through Indian monsoon. Means the first significance is that it is the main source of water for agriculture in India. Almost 60% of the agriculture in India is dependent on monsoonal rainfall. Next is relief from summer and heat waves. We know that in the month of April, May, June, most of the northern India, under direct influence of the sun rays, is suffering from high temperatures of say 48 degree to 50 degree, and heat waves. So what happened is that monsoonal rainfall used to reduce these high temperatures of summer, and it used to means reduce the impact of heat waves in this northern and central India. So this is the second significance of Indian monsoon. Third is groundwater recharge or aquifer recharge. We know that especially in the month of April, May and June, due to extreme heat conditions in the northern and central India, large amount of surface water gets evaporated and it leads to increase in the groundwater extraction by the farmers and the people. So what happens, the groundwater level used to reduce, but what happens in the month of June when monsoon used to enter India, the monsoonal rainfall used to recharge that groundwater or aquifer to ensure that the groundwater availability is maintained. Next is hydroelectricity production. Now due to rainfall, due to monsoonal rainfall in the month of June to September, October, what happened that the dams used to get refilled by the water, means enough amount of water is present there, and then that water is then used to produce hydroelectricity. We know that certain height of or certain amount of water is required because that potential energy is then converted into kinetic energy to run the turbines and produce hydroelectricity. So certain amount of or certain level of water needs to be maintained in the dam for producing hydroelectricity, and that is only due to monsoonal rainfall. And final fifth one is the recreational activities and boost in tourism. See, we know that during the monsoon, what happens that we see that different waterfalls means become active. Also means lakes which were earlier dried up, they again are means filled back with the water. So all these activities means waterfalls and lakes, recharging of the lakes and active waterfalls used to create tourism in that places and used to boost the recreational activities for people. So this is all about the significance of Indian monsoon. This was the last topic under this main heading, mechanism of Indian monsoon and rainfall pattern in India. But actually what happened that I forgot one heading under, means one topic under the factors affecting monsoon in India. You can note down that also. With this we will end this lecture. That topic is actually maiden Julian oscillation, MJO. You might have seen this heading several times in newspaper or in the current news. So this is also mentioned, this heading under the main heading which we have covered, at factors affecting Indian monsoon, maiden Julian oscillation. See, what is maiden Julian oscillation? First, why the name? Because it has been discovered by two different geographers. One was having name of maiden and another was having name of Julian. So since they discovered it based on, or they first witnessed this phenomena, so based on their name, it has been named as maiden Julian oscillation. Now write down there is its definition. That what does it mean? It is nothing but coupling of winds and clouds and their movement eastwards with speed of almost 30 km per hour in the tropical Pacific and Indian Ocean. So note down the definition for this maiden Julian oscillation. It is nothing but the coupling of winds and clouds and their movement eastwards with the wind speed of almost 30 km per hour in the tropical Pacific Indian Ocean. Pacific and Indian Oceans. See, so we have seen that this both Pacific Ocean as well as Indian Ocean, and we consider this as the tropical portion of this both Pacific Ocean and this Indian Ocean. Means this is the tropical region of the Pacific and Indian Ocean. So what happens that Madden-Julian oscillation is nothing but a large number of clouds. They are moving under an influence of a wind in the eastward direction in the tropical region. And what is their speed? Their speed is almost 30 km per hour. And how this coupling or this Madden-Julian oscillation impacts the Indian monsoon? See, if in the month of June or July, if this means Madden-Julian oscillation, if this is over Indian Ocean or this portion, then what will happen? It will boost the monsoon. But on the other hand, if the same phenomena, Madden-Julian oscillation, in the month of June and July, if it is over here in the Pacific Ocean, this moves in the tropical water from Pacific Ocean towards Indian Ocean and so on. So its location is very important. Means if its location, especially in the month of June and July, decides its impact on Indian monsoon. If the Madden-Julian oscillation is over Indian Ocean, then it will boost the monsoon, and if it will be over Pacific Ocean, then it won't boost the monsoon, or it will have a negative impact on monsoon. So I hope you people have noted down this also. Also the chart which I made earlier means what are the factors and how they are affecting Indian monsoon. Under that you can also add this Madden-Julian oscillation, and then next to it you can write down that if this Madden-Julian oscillation is over Indian Ocean, then it is boosting Indian monsoon, and if this is over Pacific Ocean, then this is reducing Indian monsoon or negatively impacting Indian monsoon. So I hope you people have noted it down. So with this we come to end of this topic, mechanism of Indian monsoon and rainfall pattern in India. In our next video we will study some other topic of geography. Thank you.